And we're live. Hi, everybody. Just want to make sure that we're going live for real this time because I had way too much of a trouble with the internet and nothing seems to be working. So just hang on with me. I'll get to what the video is about here in a second. And I'm using somebody else's thumbnail, so I got to fix that. We are here today because everybody seems to go bonkers whenever I attack Richard Dawkins or an atheist on evolution. And so I just really wanted to tackle that today. I figured that's a good thing to tackle, right? Everybody agree? If you guys, when you guys get in here, can look at the chat and just make sure everything's going right and somebody can comment down below, hey, we're good. I'd love that. But without further ado, let's get into all of this. First thing I have to do, and I'm sorry to have to do this while the show is running, I have to go and change this thumbnail. Give me 2 seconds. Gotta open this tab, get everything over, but we're gonna take a different approach today. And that approach that we're gonna be taking is I'm gonna ask AI to tell me what the most recent things that have been found to prove evolution are. And then I'm going to go and take those things and I'm going to go and hopefully debunk them. So I'm getting everything set up. I'm using half my brain power on the computer side, half my brain power trying to talk to you guys, tell you what we're going to be doing today. Little spoiler, I already asked to see if the AI was able to handle this question well, and I found out it does. So I know generally what it's going to answer, but I've not prepared any answers to this. I just wanted to make sure it would have a general conclusion of being able to get to the information. Okay, if you refresh the tab, you'll see our general hangout with us thumbnail, and I do want this to be a hangout. So I'm going to get the pin up here in just a minute after I do my main opening, and then if you guys want to jump on, that's all great. Okay, let's look at the comments. Better than using somebody else's thumbnail. Awesome. Gangster Ghost, the Real Talk podcast. Hi, Gangster Ghost. Okay, so Tim just called me back. Well, screw you, Tim. You don't get to get called back because I called you so many times before the show started. I figured it out on my own. Thank you, Tim. I'm going to use the Meta AI app. So this is not a promotion, obviously, because I doubt they would ever have me promote them using this. But Meta AI is fairly smart. It's helped me with workouts and everything else. And today, I'm going to be using it to give me content to make evolution look stupid. So thank you to the artificial intelligence. Let's get talking. Let me know if you guys can't hear this. I hope you guys can. Hold on. Okay. Hey, Meta, how you doing?
I'm doing great. Thanks for asking. How about you?
Let me turn up the volume.
Sounds good. Go ahead and adjust the volume to a comfortable level.
It does talk a little much, so I might pause or mute it here and there, but I'm excited. Okay. So I've been looking at the idea of evolution lately, and I've wondered what the best new evidence for evolution is. Can you give me a bullet point list of the best ones that are new?
That's a great question. There's some fascinating new evidence for evolution. Scientists have made breakthroughs in understanding the origins of life, particularly with the RNA world hypothesis. Researchers at the Salk Institute have discovered an RNA enzyme that can accurately copy other RNA strands while allowing new variants to emerge. This finding supports the idea that early life forms could have undergone Darwinian evolution on a molecular scale. Additionally, recent studies have shed light on evolutionary adaptations in various species, such as the discovery of a new species of velvet worm and insights into the evolution of reptiles and ancient humans.
Can you explain that last point a little better? I don't know exactly what evidence they found for evolution.
The discovery of a new species of velvet worm is significant because it highlights the ongoing process of evolution. Velvet worms, also known as Peripatus or onychophorans, are ancient creatures that have been around for millions of years. By studying their genetics, morphology, and distribution, scientists can gain insights into how they evolved and adapted to different environments. This can provide evidence for evolutionary principles such as speciation and adaptation. The new species likely exhibits unique characteristics that distinguish it from other velvet worms, which can be used to infer its evolutionary.
Do you know the name of the new species?
Unfortunately, I don't know the name of the new species of velvet worm you're referring to. The information available only discusses general characteristics and diversity of velvet worms, mentioning around.
Okay. Here's what I got so far. And I just want to, let me see. I just want to clarify what we're going to be doing first. So our first one, I opened a tab, RNA world hypothesis. So I'm not exactly sure what the world hypothesis is, but I'm going to share my screen and I'm going to let this definition take over. So Buckingham is currently sharing his screen. I hope you can see this right here. It says you guys can see it. The RNA world hypothesis proposes that RNA, rather than DNA or proteins, was the primary form of genetic information and catalyst in early life on Earth. It suggests that RNA could have both stored genetic information and catalyzed chemical reactions, allowing for self-replication. Okay. What proof do they have for that? I mean, I see that they have a hypothesis. I don't know what proof they have. Quaker Jake says hi. Ryan says, hey there, Jeremiah, what's up? Why didn't you tell us? Spontaneous. That's exactly what it is. I'm just being spontaneous. Let's boost the engagement. So Tim says, let's boost the engagement. Hi, brother Jeremiah. Thank you, everybody, for supporting. Now that we have 3-4 moderators in the chat, hopefully I won't have to look at it as much, but I'll try to catch up with you guys if you do want to say something. I'm just not going to have to police everybody better. Yeah, so Tim says, the atheist's favorite fairy tale. Oh, I love that. I love, you know, if you want to get someone riled up, this is how you do it. Okay. RNA world's hypothesis. You know, I'm going to ask Siri, not Siri, Meta. I'm so used to Siri. I'm going to ask Siri, and I can't screen share Siri because he's on my phone. Meta, I can't screen share Meta. Let's tackle the RNA hypothesis first. Why does the RNA world hypothesis prove evolution?
The RNA world hypothesis proposes that early life on Earth was based on RNA, which played a central role in storing genetic information and catalyzing chemical reactions. This idea is important for understanding evolution because it suggests a possible mechanism for how life's complexity arose from simple molecules. The hypothesis implies that RNA's ability to act as both genetic material and catalyst could have enabled the emergence of self-replicating systems. These systems would then be subject to natural selection, driving the evolution of more efficient and complex RNA molecules. Over time, this process could have given rise to the diversity of life we see today. The RNA world hypothesis provides a framework for understanding how life's building blocks could have originated and evolved into more complex forms.
What is the catalyst? Forgive me, I'm ignorant in this area.
No need to apologize. In the context of the RNA world hypothesis, a catalyst refers to a molecule that speeds up chemical reactions without being consumed in the process. RNA molecules, specifically ribozymes, can act as catalysts, facilitating reactions that are crucial for their own replication and function. Think of it like a key that helps unlock a specific chemical reaction, allowing the RNA molecule to make copies of itself or perform other essential functions. This catalytic ability is important because it suggests that RNA could have played a central role in the emergence of life's early biochemical processes.
Okay. So what I'm getting at here, and I put it up here so you guys can see it as well. That way Meta gets to be part of the show. What we're getting at here looks, how do I put it? What they're saying is they found this catalyst, and a catalyst is something that helps chemistry move faster. And then they're saying RNA, which is like DNA, and I may be explaining some of this wrong. Forgive me. I'm not a genetics specialist, but what they're saying is this catalyst can make RNA evolve faster. If I can dumb it down for all of you, I tried to pay attention while I was setting this up. Here's the problem, though. It does not prove evolution. It just says that they might not need as much time, which, if you ever watched any of Kent Hovind's stuff, he always says time is their god. Time. We need more time. And that's exactly it. They never had proof for all this time. They never can show that this time actually exists. So they say, finally, hey, we're relieved we don't need so much time. Why is that such a beneficial proof for evolution? Why is having less time proof? Because they know that time is adding to their fairy tale and it makes it less believable. Ryan says, calling all trolls. I'm waiting for him too. I'm waiting. We got all the moderators in here. We got blue wrenches galore. Okay. So then let's look at our separate one. And this was the velvet worm. I have some pictures here. I looked up velvet worm. And I found these things. Look at that. Look how nasty those look like. I don't know what that is. What are velvet worms?
Velvet worms, also known as Peripatus or Onychophorans, are a type of ancient animal that belongs to a distinct phylum. They're soft-bodied, worm-like creatures with a velvety texture.
Of course it's going to say
found in moist environments, such as under logs or in leaf litter. Velvet worms have a unique body structure with a series of legs and a pair of antennae like appendages. They're predators that capture prey using a sticky slime they secrete from their bodies. Velvet worms are often considered living fossils, providing insights into the evolution of ancient animal groups. They're fascinating creatures that have been around for millions of years, and scientists study them to learn more about the history of life on Earth.
I love this one. I was just thinking, this almost looks like a Pokemon character, and boom, right there. That is hilarious. Okay.
Hey,
let me hold on. Shut up. Okay. If you don't turn him off, he'll just keep responding to everything you say. So I gotta tell him when to talk and when not to talk. But that was hilarious. So some of them look kind of cute in my opinion. But what we have here is a worm. They say it lasts for millions of years, and we found a new species. So here's the thing about finding a new species. Until we are everywhere in the world all at once, we cannot say we know for a fact that this new species just recently developed. All we know is that it exists. And here's the thing. A velvet worm is still a velvet worm. Let me put it like this. You have black people and white people and Asians and Indians and Hispanics and all these different groups of people. Are we different species? No. We're all humans. We're not different races. I mean, race is a word that was made up to define these things, but we're all humans at the end of the day. We're all the same. Sure, some are darker skin, some are lighter skin, some can grow long hair, some grow short hair, all that whatnot. But at the end of the day, we're humans. This is a velvet worm. Now, I can't see the image of the new velvet worm that's been found, but at the end of the day, it's a velvet worm. So we're just gonna leave it at that. I can't think of anything that proves evolution off of that. Okay, so finding a new species doesn't necessarily prove evolution. It just proves that we found another animal. And as far as the RNA goes, just because RNA can have faster chemical reactions doesn't prove mass evolution. It just proves that chemical reactions can happen. Are there any better recent evidences for evolution?
Interesting question. You're right that discovering a new species doesn't directly prove evolution. Instead, it adds to our understanding of the diversity of life and can provide insights into evolutionary relationships. Regarding the RNA world hypothesis, you're correct that it doesn't directly prove mass evolution. However, it does offer a possible mechanism for how life's complexity could have emerged. One area of recent evidence for evolution comes from comparative genomics. By studying the genetic differences and similarities between various species, scientists can reconstruct evolutionary relationships and identify genetic changes that have occurred over time. For example, studies have shown that humans and chimpanzees share a significant amount of DNA, which supports the idea that we share a common ancestor. Another area of evidence comes from observations of evolutionary changes in natural populations. For instance, scientists have documented the evolution of finches on the Galapagos Islands, where changes in beak shape and size have occurred in response to environmental pressures. Additionally, the fossil record continues to provide valuable insights into the history of life on Earth. Transitional fossils, which exhibit characteristics of both ancient and modern groups, offer strong evidence for evolution. These lines of evidence collectively contribute to our understanding of evolution and the history of life on Earth.
Hold on just a second. I'm taking notes. Couldn't hear me.
Hey, I'm still here.
What was that first one again? Human and chimpanzees share 90% or something DNA?
You're thinking
I actually had a conversation with this one before.
Humans and chimpanzees. It's often cited that humans and chimps share about 98.8% similar DNA. This similarity suggests a recent common ancestor and supports the idea that humans and chimps have evolved from a shared ancestral species. The similarities in our DNA highlight the close evolutionary relationship between the two species.
Okay, so we are muted right now, so it can't see us. I'm gonna mute that for a second so it stops talking. Because it will check up on you in a couple minutes if you don't respond. So just so you know that the AI is not mistaken when referring to the mass internet. What we're gonna pull up here, fossil record, human chimpanzees. I had to quickly type all these down as it was giving them to me. So if you look right here, I can see my mouse. They share about 98 to 99%. Okay, 98 to 99% means that there's only about 1.5% difference between humans and chimpanzees, and that seems to be a big oh no problem. And I would normally be like, yeah, that does definitely seem like a problem. But then I'd wonder, how about mapping the entire genome? And then I got to realize, hold on. So there's this thing, and I don't know if I'm gonna be able to look it up as of like today, but there's this thing where they take this portion of the human DNA and this portion of the animal DNA and they combine it and they say, whoa, we will have very particular similarities. What they don't do is they don't look at the entire stinking genome and compare the entire stinking genome. I mean, just look at this. Okay, so if we take a step back and we go to Ignorantville, I'm not going to stay here long. Human chimp. Let's pull up this image right here. Human chimp. Do they look 99% similar? I'd not say so. Now, that's from an ignorance perspective. We can go back to the intellectual because sometimes things look weird like at first, and then when you actually dig into it, they make sense. But here's the thing, and here's what I'm getting at. So lots of scientists have done research and come to different opinions, and I would like to share with you the opposite opinion. And that is that they've taken specific parts, said, wow, these parts are similar. They don't look at the rest. So they see that, yes, chimpanzees have eyes. Congratulations. Chimpanzees have ears, arms, legs, hair, mouth, teeth, heart, organs in general. Yes, we are fairly similar. At the same time, though, we are massively different. So let me just mention this piece of information to it and see if it agrees with me or not. Now, I will say this, and we'll get into more of it later. The AI is programmed to not be confrontational. It will still disagree with you if it knows for a fact you're wrong, but it tries its best to be non-confrontational. So don't take the lack of confrontation as me winning or me beating it, but look at what it actually says, okay? What about the idea of some of the DNA being compared, but not other parts of the genetic genome? Is the entire genetic genome only 99% correct? Or are they only picking and choosing certain parts, like cherry picking?
Amazing question. When comparing the human and chimpanzee genomes, scientists typically look at the DNA sequences that can be directly compared between the two species. This means they're focusing on the parts of the genome that are shared and have a clear correspondence between humans and chimps. The 98.8% similarity figure is based on comparing the DNA sequences that are considered orthologous, meaning they have a common ancestral gene. However, there are parts of the genome that aren't directly comparable due to insertions, deletions, or other genetic events that have occurred over time. So, it's not necessarily a matter of cherry-picking specific parts, but rather comparing the DNA sequences that can be reasonably aligned and analyzed between the two species. This approach allows scientists to estimate the overall genetic similarity between humans and chimps, while also acknowledging that there are regions of the genome that are more divergent or difficult to compare.
So when let's just say I look at a full genome of a chimpanzee, and I looked at the full genome of a human, and I took into account that certain parts were completely missing, which does count as a difference. Would it be less than 99% then?
When considering the entire genome, including all the differences, the similarity between humans and chimpanzees would likely be around 85 to 90% or so. Rather than the higher figure often cited, the exact percentage can depend on how the comparison is done and which specific genomes are being compared. But overall, accounting for all the differences would indeed bring the similarity percentage down from the 98.8% figure.
So do you hear that? Now I'm just asking the right questions. I'm not arguing with it. I'm just saying, what about this? What about this? I'm just being curious. I'm just asking the right questions. And it's saying, well, when you look at the fact that huge pieces are missing, yeah, sure, they can be a little bit more different. Let me give an example. I have two pieces of paper here. I'm going to draw them and I'm going to show them to you. Okay, hold on. The first piece, I'm going to have a line, okay? On the second piece, I'm going to have a line and a couple of dots. So you can see right here, these two pieces are fairly similar, okay? They even have the red line on the right piece. They all have the same lines. If it wasn't for what I drew on them, they'd be almost exactly. But this one has one line, this one has two lines and a couple of, well, that has one line and a couple of dots. So these are 99% similar. Okay, well now hold on. Are they still 99% similar? We still have the one line on both pieces. We still have the dots. So these are very comparable. We have the red line, we have the blue lines, we have the black line, we have the dots. So that's the 1% different. But hold on, this one's completely different. These are not the same thing. Not at all. Well, he said, well, we compared all of this at the top. We didn't compare anything down here. Well, that is what I define as cherry picking. If you combine all this, you're looking at, what was it, 87, 88, 90%? 90% instead of 99%. That margin's huge. I just want to point out how much they're lying to you and how much they're trying to warp you. Now, that's not even my argument, because that's just different. I'm just pointing out to you, hey, they're lying to you. They're making it look like we're 99, when in all reality, we're more like 90% when you look at the big picture. Yeah, there's parts that look similar, like we both have eyes and we both have hands, but there are other parts that are very different. And you can't just look at one and not the other. They said, well, we only compared the parts that were comparable. Well, that's apples and oranges. If I said, well, I'm only going to compare the apples to the apples, and oh, look, I have 100% apples here. Well, what about the oranges that are 50-50 mixed in? You have to look at all of the picture. Come on, guys, don't be idiotic. Okay, here's my more important thing, though. So let's just say 99%. Okay. And how does 99% prove evolution? There's no proof in 99%. There's an argument, I forget exactly what it's called, but it's like common features prove evolution. Let me see if I can find it. Common features prove. Let me see if I can prove I spelled that wrong. Prove evolution. And I'm in a rush right now because I'm trying to keep it fast moving and fun. So I'm going to misspell a whole lot. I'm going to let the computer do the rest. But I'm looking for some images that everybody has probably seen. Everybody. Here we go. Let me see if I can share this page. Start. Comment. Okay, here we go. And we're going to look at this picture right here. Everybody's seen a picture like this before. Look at this bone and look at that bone, and all these creatures have a similar bone. Well, first, we named it. So, of course, they all have the same name. Let me turn on my camera here. Of course, they all have the same name. But at the same time, we could do the same thing with cars. Let's just step back, okay? Let's go into more ignorantville again, because I believe that it should be able to be explained to the ignorant, okay? And we're not all scientists. So let's just go down to the people who don't look at all this. Okay, I have a bone here, and a bone here, and a bone here, and I think this last one's kind of silly, but let's just look at these first three. 3 different animals, 3 different structures, all use similar bone stuff, and they all have the same purpose. More importantly than the same name, which I think is just a human concept, they all have generally the same purpose, and it's to rotate the wrist. That's what it does. So, a bone that rotates the wrist, fairly useful. Have you ever seen a car? Hold on, let me look up cars real quick. I can spell that word quickly. Hold on, okay. And then let me just switch my screen share to a different tab. Not now, images. Okay, and then I'm gonna screen share again. And you guys, you already know what a car looks like. I don't need to show you what a car looks like, but I'm gonna do it anyways. Okay, here we are. Cars. Notice anything similar? So here's a Toyota. It has 1, 2 wheels on this side. Probably, if I'm guessing, 2 wheels on the other side. Okay. Here's a Hyundai, I believe. I can't see that logo too close, but I think that's a Hyundai. Yeah, it looks like a Hyundai. Oh, look, 1, 2 wheels on this side, maybe 2 wheels on the other side. Okay. So I believe that these cars evolved from each other. Okay, well, this one looks cooler than the other one because Toyota looks, was it Toyota that I was looking at? Yeah, this Toyota, you can see like it elongated over time, and it started camouflaging. I'm just making this up as I go. It started camouflaging and it elongated, so it goes faster, and it like stretched out more, and its wheels are even more snazzy and higher aerodynamic, or whatever you want to call it. And the grill got thinner, so it evolved over time. Yeah, sure, I can make it sound remotely reasonable, but is that how it happened? No, we know how this happened. Somebody built this. And guess what? Wheels work. So somebody else took that same idea, like this Mercedes over here, and they took wheels that work. Cars have 4 wheels. Some have 3, but we're not going to talk about those. So when it comes over here to our limbs, or 99% similar genetic code, guess what? A common creator would say, this works. Let me use it again and again and again. So I don't buy it for a second when somebody says, hey, this is going to be an evolution proof. No, it means that the design worked and the guy used it again. Now, am I speculating? Sure. I don't have definitive proof, but neither do you. I've been looking. I can't find it yet. I'm going to do this next week. Same bat time, same bat channel. But what we're seeing is common similarities. You can come out to very different viewpoints on that. You can come out to, everything we know in society means common designer. Humans took the same blueprints. Maybe aliens, who knows? I'm not trying to come to a conclusion, but I'm just saying evolution here does not match any of the answers we've found so far. So to say 90% similarities, that's crap. I'm not. So human and chimpanzee sharing data, sharing genetic code. First, they don't share as much as they try to trick you into. Okay, they just don't. It's more like 90%. And then even if it was 99%, I have 2 cars in the driveway, and they have similar wheels, airbags, doors. They have the same amount of doors. They have folding seats. They have a radio. They have speakers. They have so much stuff in common. They got 2 headlights in the front, one on the left, one on the right. So many stinking things in common. Similar designers. Okay. Let's get rid of this chimp window. We have a lot of ground to cover today. Finches. For those who don't know what a finch is, and this is not new genetic stuff, but sometimes the most revolutionary tech isn't brand new. So, finches. Here's a guy who, Charles Darwin, and I could go into a whole show discrediting Charles Darwin, but I'm not going to, because it's not about the human, it's about the argument. So, here's a finch. It's a bird, it has a beak, pretty basic. Charlie Darwin found these things on an island. He found them with beaks. He's found some with bigger beaks, some with smaller beaks, and was like, wow, look at them evolving. Again, we have black people, white people, tall people, short people, fast people, slow people. We got people in all colors, shapes, sizes. You can, pick and match whatever you want. Here's the dilemma, though. They're still people. These are still finches. Now, I come from a biblical perspective. So let me just clarify what I believe. I believe in the Bible, in Genesis particularly, first few chapters, it says that God created them after their kind and that they would produce and bring forth after their kind. It says it so many stinking times in the first chapter. If you read the first chapter, you'd find after their kind, after their kind, after their kind. A finch is going to produce a finch. That is actually biblically accurate. You cannot find any proof that something does not produce after its kind. However, they're going to say, look at this finch with a longer beak and look at this finch with the shorter beak. Okay. I know some people with big noses and some people with small noses. Doesn't mean anything other than people change a little bit. And I did want to get into that. Animals do change. It's this idea of evolution that is the problem. If you have a pig and you breed it to be bigger, okay, it gets bigger. You breed it again to be bigger and it gets bigger. There's only so much strain the genetic code can take before you went too far. How big do you think you can get a pig? Can you get a pig as big as a cow? Sure. Maybe. I don't know. I don't know how big the biggest cow is. I don't know how big the biggest pig is. Could you get a pig the size of a state? Even a tiny one, like New Jersey. I think that's a state. Anyways, my point is, can you get a pig the size of a city even? No. There are limits. Hearts have to pump blood, different things have to... The genetic code can't engineer for that. And it dies. So the thing is, when trying to make a big pig, there are limits. When trying to make a small pig, there are limits. Do you think you can get a pig that is around the size of your house cat? Sure. They actually have those. My sister has one of those. Do you think you can get a pig the size of a bumblebee? Maybe. I doubt it, but maybe. I'm not going to leave it out there. Do you think you can get a pig the size of an atom? No. Just wouldn't work because atoms. So the dilemma is there is a limit. Do you think you can get a pig to grow feathers? No, there's no genetic code for a pig to have feathers. Pigs won't fly on their own. And I know some people are going to disagree with me, but when you show me the proof, there is no proof. Anyway, I'm going to take out the Finch page. Fossil record. Oh my. Oh my. How many tabs did I open for this? We got 3 more tabs to go, I think. Let me check the comments. Good grief. Ryan, you're going crazy in the comments. I love it. Okay. Oh no, I broke it. I broke it. Can you get a pig to fly? I love that. Okay. So we're going to get to our next tab. We have 3 more tabs to go. We have the fossil record. Okay, fossil record here. The fossil record is a collection of all the preserved remains, impressions, or tracks of past life. Okay, I'm going to share that page. I want to make sure that you guys can see this, that I'm not throwing anybody under the bus. Let me share my camera again. I don't like that. They should make a toggle switch back and forth. Okay, so here you go. Let me make sure I can see this. So the fossil record is a collection of every trace of past life we've been able to find. What you can find in that is density sorting and different stuff like that. You can find evidence of previous bone structures. Let me look at the images right here and see what they can find. Okay. So you have these classic images of these towers, and I'll get to that in a second. First, let's look at some actual stuff. We're going to do some science here. You see this image right here? Nice image right here. So if I'm looking at this, what do I see? Do I see millions of years? No, I do not. What do I see? I see a dead remain. Actually, it looks like more of an impression here. This one might be a little bit more of an actual fossil. That one looks more like an impression, like it went and like squished itself into the ground. But I'm not seeing how old it is. There's no proof that this had kids. We know it had parents, probably, like from what we can generally infer. It had parents. So cool. How old is it? I'm not exactly sure. I could carbon date this thing, but we might get into carbon dating later. It sucks. Carbon dating is not reliable. Every time when we know how old it should be, it's wrong. So we can't carbon date it. We don't really have any dating methods that actually work. And maybe we'll have a show on that later. So what we know here is there's an animal. At least I guess it was an animal. And it died. And it was somehow impressed into the rock, which normally takes water. Like water and, like sandstone or something. It presses it in like a mineral that really likes water and all that whatnot. Let's look at another one. Okay, let's look at this one. This one looks fun. This one we have bone structure. Okay, so we know that bones go to animals. We know that this is definitely like an actual fossil, not an imprint. Definitely, in my opinion, looks like some kind of dinosaur, if I had to guess. How old are you? I don't know. We have no dating methods that work. Okay, so some people say, well, the carbon dating doesn't work. You can date them by the layers. The farther down you go, the older it is. Okay, so down here would be really old at 2.5 billion. Up here is humanity, and the further down you go, then the older it is. Well, here's the thing: there's no place on Earth where all of this stack actually fits. There's no such place. And that's a very big problem because it means that this chart, the fossil record, doesn't exist anywhere. It's not shuffled like this. It's just not. We want to say the Jurassic period, but there isn't a Jurassic period per se. And we found fossils that are together that shouldn't be together. I think there's one. I don't want to overreach, but let me see if I can find it. Where a human footprint and a dinosaur fossil were together. Let me see. Human footprint next to dinosaurs. Oh no, let me see what I get. Okay, claims of a human footprint next to dinosaurs. Yeah, I've seen this before. Look at this. Look at this. Let me stop screen sharing that page. Let me open up this page. Look at that. Hold on, there you go. What is that? That's a human footprint. What's this? Dinosaur footprint. What is this? Human footprints. What is this? Dinosaur footprints. Tons of tracks of human and dinosaur footprints found together. We got one right here, looking at dinosaur and looking at the human, and they're like, oh crap, human and dinosaur footprints. They're like, hold on, something here isn't right. We have tons of images of human and dinosaur footprints found together. So we can go back over to this original page, the column over here, if you will. Let me screen share that again. Fossil record. This fossil record shouldn't make any sense. It doesn't. It just doesn't. This is a lie. the Jurassic period, but then we find human footprints in the Jurassic period, and there's several others. I could go on about this. I could. Anyway, so they'll say, the older down you go, but then we find all these things shuffled, more or less. So that doesn't work. It just doesn't. And then water flows and moves around, and if fossils are created by water, oftentimes, the water can shuffle things. So really, it doesn't prove anything. So that we found as an assumption. Transitional fossils. So moving on from that, we can't date any fossils. We know that. We just know it died. That's what we know. So we can't assume, we know for billions of years if there's no accurate dating methods. Transitional fossils, also known as missing links. Well, first they're missing as, for a reason. Show me a transitional fossil. You can't find one. You find something that died. So if we look over here, we can actually find some images that they claim to be transitional fossils. If I click on images, and I'll show this to you in a second. Here we go. Let me open this up. Transitional fossils. And hold on, we have, hold on, I think we only have one tab left and we're on it. Let me see. Yeah, common features tab, I should delete that. We only have one tab. So we're almost done today, I believe. We've been on for 41 minutes, so we're good. So here you see we have similar fossils. Let me see if I can't make this a little bigger. We have this fossil, which is pointy, this one that's less pointy, and this one that's even more less pointy. Okay, you found 3 animals that died. You cannot prove that these are the same creatures. You ever seen that one where they they take a hippo skeleton and they say to an artist, make this into a creature. Draw this into a creature. Make it as accurate as you think can possibly be. They've never seen a hippo skeleton. And they try. And they completely mess it up. Hippo skull. Let me just show you what a hippo skull looks like. Bones. Okay. Let me share this with you. Stop sharing and share hippo skull. Here we have a hippo skull. These huge teeth on the outside. And then you have all of this going on the inside. So it's a little hard to know exactly what a hippo would look like. Okay, here's another picture. Look at this creature. That doesn't quite look what you think a hippo would look like. Like this looks like a horrifying creature. Hippos are nice, cute, and chunky. Why does it look so horrifying? So they had an artist draw over this, and they just absolutely messed it up because they didn't know what a hippo skeleton looked like, and they saw this, and so they just drew over it. Let me just see if I can find out anything about this. Let me see. I don't know if I'm going to be able to pull it up. Here it is. Here it is. This is, and I know it's small. You might not be able to see it. I'd like to make this bigger if I can. Here it is. This is what they thought it looked like. They removed a lot of the fat, and they were like, this is what it might look like. And then this is what it actually looked like. So this one makes fun of it, how aliens would reconstruct the animal, because that's what we do. This is what we do to other creatures. We don't know. Have you ever seen a beaver tail? Hold on. Beaver tail. Okay. I know, I'm doing a lot of sharing tabs here. Share tab. Beaver tail. Okay. Look at this. Look at this. The beaver tail is a spike. Since when was a beaver tail a spike? So if I were an artist and I've never seen this creature and the tail was not preserved, how do you think I would make this look? I'd probably make it look something like a cat tail or a rat tail. I wouldn't make it look like this. But you don't need bones to go through this entire thing. You just need the one, vertebrae line, and that's it. So, you get to this and you realize how much of our claimed science actually becomes speculation. They don't know. They don't have transitional fossils, and they don't even know what the fossils look like. None of us do. We look at dinosaurs and we make a big fat guess. We don't know. We just don't. Okay. Well, that's it. That's all I got. So the main point of this is to realize how stupid evolution is, how wrong these people are, and how brilliant they think they are for imagining. I swear these people are on shrooms and, LSD or whatever it is. This is not science. This is imagination. Now, I personally believe the creation side, and we can get into that on another day. But my point, first of all, right here, is to just kind of poke fun at all the atheists, because they seem to really like it when I do it, and they seem to leave lots of comments. So I'm counting on you guys. Have a good one.